Hi, good morning all. In today's session we talk about the Spring Boot and Docker integration. First of all, we'll just see the history of the Docker. So earlier you know that our Java application is hosted onto standalone system or bare metal server. So this is a server. Okay. So initially we are deploying our application on a server, but in a such scale. So if you want to scale that system with the multiple servers, it's not that easy. So as the time moves, we are started to split this server on a multiple VMs, like VMs on a single machines. There are multiple VMs, and on a particular VM we are deploying here one instance, here one instance, here one instance. Still the chances of the improvement is there. So for that the Dockerization came into picture, Dockerization and containerization. So in a Dockerization, what happened? Docker allow us to write application, deploy and scale application in a certain way so that we can achieve maximum throughput from the hardware. Okay, so just an example, this is our infrastructure which is to have a 20 cores. This is a 20 core, but and based upon this is the host OS, and 20 core and 20 RAM we have, but we don't want to provide all that to the single application. That's why Docker came into picture. On Docker, multiple containers getting run, and on per container the CPU and memory get allocated, because each and these containers have its own OS and all stuff are there. Nothing is shared by the Docker. That's why I'm saying the definition here. We are saying what is the Docker. So Docker is the software, or Docker is allow us to write, run, build application and execute that application independently, or we can say application are containerized and run on the Docker. Okay, that's it. Why it's required? We check that to get the optimum result from the hardware. Docker came into picture. Okay, this is the why and what. So let's check how to integrate our Spring Boot application. Like this is the app A. So how to achieve this? This is the container. This is the container is getting built and run on a Docker. Okay, on a Docker. So if our application, okay, this is our application. First we need to compile that and build certain jar or output of this put into certain OS or attach with the OS and prepare OS plus jar, combine this as an image and run this image on the Docker. Okay, this is the flow. We'll check and how to do that in example section, but this is an overview. Okay, so first of all we need to define the app. For here we are checking how to Dockerize our application. So we are not running the complex application. I'm just writing the one REST controller, Spring Boot controller, where get mapping is there, and here welcome, whatever name I am passing, that is getting printed. Hello, my name Ram and welcome to website. This is just method get printed on the browser. Suppose if I run that MUN Spring Boot and run application, the application started on 8080 port. So when I say localhost 8080 welcome Siri, so I get that message, welcome Siri and welcome to my website. Okay, this is a very simple application. We are checking Docker, not the Spring Boot application. Okay, so our application is running. So first part is we need to build some artifact out of that. Means we need to build image for that. So first we need to do MUN clean install. So after MUN clean install, jar is created. Okay, jar is created. But before that, we need to set up a Docker file for our application. So how to do set up Docker for your OS? This is the link, like docs.docker.com, get Docker. Here the Windows, for Windows they are set up different one, for Linux they are provided different, and for Mac they are provided a different links and software. So you can easily go and download it. There are steps also mentioned. If you face any problem, let me know, we can resolve it. So in your application, Docker file need to create. Just go and create an empty Docker file. Put this 4 line into Docker file. What it means, like from Java 8 SDK Alpine. Alpine is the OS. So you want one Docker or a one container which have Alpine as OS, base OS for your. This is a Linux distribution Alpine, and Java 8 is required. Java 8 is required for you running your application. This means like this. Copy.target this sample snapshot jar. Copy from user app. Right now your working directory should like user/app, because this sample snapshot dot we copy from source to destination, and henceforward our application destination or whatever command we are executing, that working directory is a user/app. Our entry point application means Java. To run this jar, we are saying Java -jar and this sample.jar. That means this sample.docker.jar, this is run through this entry point command. Okay, so till now what we are saying in a Docker file, I want such an image or a container which have a Alpine, which have a Java 8. Apart from that, I need to copy my snapshot.jar into this, and after copying I need to run this jar by Java-jar command. Okay, these are the things we mentioned here. After that, okay, Java, what is a jar and what is an image? So jar is a contain of image. So combining Alpine, Java 8 and jar, these we are calling as an image. Okay, and this is in a small part, execution unit is a jar. So combining the runtime environment, OS environment, it's the image. Okay, so all the whatever image build, how to build this image. So first you need to, when you say mn clean install, jar is getting built, and when you say docker, this is the docker command build -t, and this is your application name. So this look like command like this. Here I added like docker build -t sample.app in the current directory that get created, and here you will get to say that successfully build is triggered and tagged as under sample.app. So docker image is getting created on this directory. If you want to see what are the properties are available for image, you just hit that docker/images. So all the current directory images getting listed here, like a sample app, image name when created, and what is the size of that image. Okay, so once that image is ready, you just need to run that, like docker like $docker. This is the docker is a command. So run, we are running that. RM means remote, P1 means port. Earlier we are saying that this is image, Alpine is OS, so this is internal OS and our host OS. So if you want to bind, okay, this is just one second, this is a container OS, this is OS, Alpine OS, which is a containerized OS. Okay, we can call it a containerized OS, but this is a run on host system. Okay, host system. So we need to bind this port 8080 to outer 8080. So for that we are mentioning here, bind this port 8080 to 8080 and run our application. When you say docker run and binding port, then you hit this sample.app, the jar getting run, and you will see this kind of console for in your system. And when you hit that localhost welcome series, similar statement you will get. That means it's the same thing, you are running application from dockerization thing. So earlier at a first place, when you hit the welcome series on a host application, your application is deployed, but after the dockerization your application is deployed inside this app1, and from here you are hitting welcome and the Siri message you will get. Okay, yeah, this is it. I think this is a high level on dockerization and containerization. If you have more doubts or if you want the detailed session, let me know. We'll do for you. Yeah, thanks all. Yeah, bye.